Today, we're going to listen in on some of the fastest heartbeats in the entire universe. And I'm not just talking fast. These are rhythms so extreme, they push the very limits of physics itself. They come from some of the most violent, chaotic places in the cosmos. So the big question is, what in the world is creating this impossibly fast cosmic drumbeat?
So what do you think it is? You might be picturing, I don't know, a spinning planet or a moon in its orbit, but nope, not even close. The answer is something way more chaotic and unbelievably rapid. We're talking about a rhythm that's literally born from cosmic violence, a beat so fast that it actually strains the fabric of space-time. Yeah, it's that wild.
Okay, so to find this beat, we have to go back in time a little bit, to the 1990s. This is when astronomers first started picking up these incredibly rapid, rhythmic signals coming from deep, deep space. Imagine hearing a faint but super fast drum beat from clear across the cosmos. That's kind of what it was like. And the thing that finally heard it was this amazing piece of tech, NASA's Rossi X-ray Timing Explorer. Now, this wasn't your typical telescope looking at stars with visible light. No, this thing was tuned to listen to high-energy X-rays. You know, the kind of stuff that gets blasted out during the universe's most violent events. And by listening in this totally new way, it found a whole new kind of cosmic music.
All right, so where were these signals coming from? The big mystery, right? Well, the satellite managed to trace them back to their source. And the culprits? They turned out to be some of the most extreme objects we know of. These cosmic pairs, locked in a super dramatic and deadly dance. They're called X-ray binaries. And here's the setup. Just picture a regular, normal star, but it's locked in orbit with this incredibly dense partner. This dense object has such immense gravity that it's literally tearing gas away from the normal star. It's like a cosmic vampire. This stolen gas gets pulled into this swirling, super hot disk that glows, you guessed it, fiercely in X-rays.
So what is this super dense partner? Well, get ready for this. It's a neutron star. This thing is the crushed up leftover core of a gigantic star that went supernova. I want you to try and imagine this. Squeeze the entire mass of our sun, all of it, down into an object the size of a city. Just a single teaspoon of this stuff would weigh billions of tons. We're talking about one of the most extreme forms of matter anywhere in the universe, period.
So as scientists started really digging into the data, studying these flickering X-rays, they realized something. It wasn't just one rhythm they were hearing. Not at all. They found 3 totally distinct high-speed signals, and each one was like a clue, a little piece of the puzzle, telling them about the insane physics happening right at the edge of that star.
Okay, so the official names are millisecond pulsations, burst oscillations, and the most mysterious one, kilohertz quasi-periodic oscillations. Yeah, I know, it's a mouthful. Just call them KHZ QPOs. But think of it like this. The pulsations are like a steady, predictable pulse, almost like a lighthouse. But the QPOs, they're way faster, and it's a flicker that's almost perfectly regular, but not quite. And each one of these signals tells its own story about the chaos going down near that neutron star.
So how fast is kilohertz? Let's put that in perspective. It means these X-rays were flickering more than 1,000 times every single second. I mean, just try to wrap your head around that. That isn't just a beat, it's this incredibly high-frequency vibration, like a cosmic hum coming from these absolutely extreme environments. This, of course, raises a huge question. I mean, what could possibly make an object that's more massive than our sun flicker 1,000 times a second? Well, scientists figured out pretty quickly that the answer had to be a combination of 2 things. First, the absolutely dizzying spin of the neutron star itself, and second, the frantic orbit of all that gas swirling just above its surface.
Okay, so the leading theory goes something like this. You've got the gas being pulled from the companion star, right? It forms that hot, swirling disk. Then, as this gas spirals closer and closer, it slams onto the surface of the spinning neutron star. Bam! This impact creates these super bright X-ray hotspots, and because the star is spinning so insanely fast, these spots whip around like the beams from a cosmic lighthouse that's been put on hyperdrive, and that's the flicker we see from Earth.
And you know what? The research totally backs this up. The scientific models that best explain these signals, they all come down to that delicate dance between the star's spin and the stuff orbiting right above it. It's just incredible. We are quite literally watching matter perform this high-speed ballet on the edge of a stellar corpse.
But look, this is way more than just spotting a cool, strange flicker in space. Being able to measure this cosmic beat has huge implications.
And that's because it lets us test the fundamental laws of physics in a place that is way, way more extreme than anything we could ever hope to create here on Earth.
Think about it. These neutron stars are like these perfect natural laboratories for two of the biggest puzzles in all of science. First, you have gravity. The gravity here is so intense, it actually warps space and time, so it can push Einstein's theory of general relativity to its absolute breaking point. And second, you have the matter itself. It's so unbelievably dense that it gives us clues about how particles behave under pressures we just can't make in a lab.
So, at the end of the day, these super fast flickers aren't just some weird cosmic curiosity. No, they're a seriously powerful scientific tool. By listening to the universe's fastest heartbeats, we're basically using a neutron star, you can think of it as a black hole's smaller cousin, as our own personal lab to put our biggest ideas about gravity and matter to the ultimate test.
You know, finding these millisecond rhythms really just blew open a new window into the high-energy universe. It just makes you wonder, right? As our telescopes and instruments get even more sensitive, what other bizarre signals and hidden cosmic secrets are still out there, just waiting for us to finally listen in?